Hello everyone, Mr. Minix, my name, math is my game. Today we're looking at part 4 of the unit circle with my Algebra 2 class. Part 4, what we're doing is we're tying together triangle trigonometry with the unit circle, okay? So we're tying together right triangle trigonometry, right triangle trigonometry with the one and only unit circle. The title's probably the most writing of the whole entire thing. If you don't have any blank unit circles before you, you'll probably want a couple. I've mentioned it before, it's worth noting again, the unit circle is about memorizing. It's about memorizing for the sake of evaluating, memorizing for the sake of evaluating, trigonometric functions for various angles. It's really what it's all about. The reason you memorize the unit circle is so that you can evaluate a trigonometric function for a various angle. What that means, what that evaluating is all about, a specific instance of this might be something like find the S-I-N-E, find the sine of 315 degrees. And the good news is, you don't need a calculator to do it. You probably already know what it is, you just don't know that you know yet. Okay? Also, you would be able to evaluate the cosine of 0 degrees. You would be able to evaluate the tangent of 210 degrees. So those are the kinds of things that this memorizing of the unit circle allows us to do. And it's really easy. It's very simple. So to show you what this is all about, we need a circle, a unit circle, one that we can look at. I'm going to send this to the back, and I'm going to make it like translucent so it barely shows up. We can see it, but it just barely shows up. So I'll lock that in place. And I'm just going to pick arbitrarily some angle on this, some triangle on this to look at. We'll just go with this 30-degree angle right here. We'll just go with this 30-degree angle right here. So we'll look at that triangle. So on yesterday, we talked about the sine and the cosine and the tangent. And right here, this 30 degrees, that's our reference angle. That's our theta. So relative to that, this bottom side, which is also a leg, is our adjacent side. That's our adjacent side. Okay? Everybody with me so far? So this is tying in what we talked about on yesterday with all this, okay? So looking over here at this other leg, that is our side opposite the reference angle. Right? And one thing that you recall about a unit circle that I said, and I said, and I said, and I meant, and I meant, and I meant that a radius is a radius is a radius is a radius. And the radius, which happens to equal the hypotenuse of this, we declared a while ago, is equal to 1. So if I wanted to find the sine of 30 degrees, I could use the right triangle that's there before you. I could use this right triangle. I could use the various parts and pieces. And I could set up a ratio that would allow me to find this out. The sine of 30 degrees is going to be the, it's going to be let's see. How do I remember what the sign is? What's the thing? The acronym? Not King Henry, not Roy. What is it? SOHCAHTOA. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Yeah. SOHCAHTOA, SOHCAHTOA. SOHCAHTOA. So if I want the sign, it's going to be what over what? If I want the sign, it's going to be what over what? Opposite over hypotenuse. So it's going to be the ratio of the side opposite to the hypotenuse. Hey, the side opposite, I might not know it yet. Maybe I do. I don't know. The hypotenuse, though, the hypotenuse I do know because it's this radius, and that's 1. So it's going to be, this is going to be the opposite divided by 1, which is really just the length of that side that's opposite. Okay. Everybody with me so far, I hope. All right. So a couple of days ago, I asked you to know what the coordinates of that particular point are, right? Do we recall what the coordinates of that particular point are? Rad 3 over 2 for the x-coordinate. Good. And 1 over 2. Remember, rad 3 over 2 and 1/2, they're a couple, they're a mate, they're a pair, they're always side by side. So if we think about that, the rad 3 over 2 is our x-coordinate, the 1/2 is our y-coordinate, right? So I'm going to try to use my creative pen here. I'll go ahead and get this smiley face. So here's a smiley face. We know that the unit circle is centered at the origin. So here's my smiley face at the origin. Maybe I'll make the smiley face bigger so everybody can see it. Is that big enough? Okay. So if I take the smiley face over here, its y-coordinate still the origin, but then if I raise it up here, wait a minute. The coordinate there's a 1/2, so the y-coordinate's still 0 over here. Y's 0, y's still 0. If I go up to here to a 1/2, that tells me the length of that side, doesn't it? Doesn't that y tell me the length of that opposite side? So what I'm getting at then is the sine of 30 is, let me see if I can highlight this. Where's my good highlighter? The sine of 30 is equal to the length of this side opposite. It's equal to the length of this side opposite, which is equal to this y-coordinate there, which is 1/2. Which is 1/2. Is everybody with me so far? Okay. So if we had to find the cosine, if we had to find the cosine of 30, let's see, SOHCAHTOA. If we had to find the cosine of 30, it's going to be the what over the what? Yeah. Nice. It's the adjacent over the hypotenuse. And because it's the unit circle, we know the hypotenuse is this, it's the radius, which is 1. And if we think about the adjacent is the distance from here, well, x is 0, out to here. It's the distance from here out to here. Well, the distance from there out to there is the same as our x-coordinate, right? So it's rad 3 over 2. So that ends up being just the adjacent, which equals just rad 3 over 2. So this is really shaping up to be something awesome, something so special, and I'm so excited I can't even grab the right highlighter. I'm going to highlight it in purple. The cosine of 30 degrees ends up being that coordinate. Do you think that's always going to be the case, where the sine is the y-coordinate and the cosine's the x-coordinate? It is. It is. So here's the take-home. Your x-coordinate is equal to the sine of whatever that angle is. I'm sorry. I better neck myself. Scratch that from the record. X is the cosine. I'm so sorry. X is the cosine. And the y-coordinate is the sine of whatever angle angle you're looking at. Now here's what I really love about math. Math a lot of times goes alpha order, right? Alphabetic order. X comes before Y, cosine alphabetically comes before sine, doesn't it? So that's one way you can kind of keep that straight. So we need to see the last one for a second. Yep. Whoop. There we go. Under the sine, we got the cosine of 30. Yep, cosine of 30. Cosine of 30. Okay. Cool. So just to confirm this, I want to go ahead and punch this stuff into the calculator. So I got my calculator handy. I'm going to start up a new document on my calculator. So on my calculator, I got to make sure I'm set up for degrees. Home 5-2 gets me into degree mode. I'm good. And we said that the sine of 30 is a half. Now that's a decimal equivalent of 0.5. Let's see what happens. SIN, sine of 30 degrees, is a half. Oh, look at that. The cosine of 30. We said we believe the cosine of 30 is the square root of 3 over 2. I don't know if anybody remembers it from about a week ago, but I said you're going to need to know what the square root of 3 over 2 is as a decimal equivalent. And that's it. It's 0.866. What do you think? Is this making a little bit of sense so far? So the awesome thing is, you don't have to have any kind of calculator whatsoever to be able to calculate the sine or the cosine or the tangent or the secant or the cosecant or the cotangent of any angle all the way around the unit circle. So what I'm trying to say is this. If I asked you what's the cosine of 300 degrees, you could find it without a calculator. What the steps required are to figure out, first of all, where 300 degrees is, and this is why I have you memorize the angles. So step one to this, where's 300 degrees? Where's 300 degrees? Where is 300 degrees? What quadrant is that going to be in? Quadrant 4. Okay, so it's going to be either here or somewhere in between. So where's 300 going to be? Right here? Okay, so there's 300, so that's where that is. There's check on that. So the second thing we need then is if we're finding the cosine, we got to realize that the cosine corresponds to which coordinate, the x or the y coordinate? The x coordinate. So now we just got to know our x coordinate, and then that's it. So really the question is, what's the x coordinate? Right there. And as long as we know that, we'll be able to answer this question. I'm hearing a half. I like it. I like a half. I'm pretty sure it is a half. When we have this reference triangle, what we're looking at specifically to answer this question is we're looking at this distance here, and we're kind of comparing that to this. We know that one of them is rad 3 over 2, and one of them is a half, and it is a half. It is a half. So the answer to this is 1/2. And if you don't believe me, let's punch it in the calculator. Let's punch it in the calculator. On the calculator, what's the cosine of 300? It's a half. What do you think? Pretty cool, huh? So, I've been holding off about telling you what big test is coming at the end of this. But I'm going to let the cat out of the bag. The good thing is you're going to know 96 of the questions before taking the test on this. You're going to know what they are. So the big test over this that's coming probably after spring break. Questions 1 through 96. Find the sine, cosine, tangent, asterisk, 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 for each angle on the unit circle. And what we're going to do today is we're going to run through question 1 and 2, question 7 and 8, question 13 and 14, etc. We'll pick up the other ones on another day. So, on the test, question 1 is going to be find the sine of 0. Question 2 is going to be find the cosine of 0. So we got to picture where 0 is, where 0 degrees is. Keep in mind that this 0 is the angle 0 degrees, which is right here, right? So to answer these two questions, we're going to need to know the coordinates there. So what are the coordinates at that particular point? 0, 1, or 1, 0. People get them twisted all the time. 1, 0 over there. Keep in mind that one of those coordinates corresponds to the sine and one of them corresponds to the cosine. If you haven't got this figured out yet, remember it's cosine, sine, x, y. X is the cosine, y is the sine. Okay? So what's the sine of 0? When we answer this question, the sine of 0 is this 0. It's that y coordinate right there. Okay? What about the cosine of 0 then? It's going to be 1. And to be clear, as mud, the cosine of 0 is this coordinate right there. So the cool thing is you're going to take a 100-question test and you're going to know the answers to 96 of the questions before you even take the test. The hard part is it's going to be in the context of a multiple choice test. I think a multiple choice is actually going to make it harder. But anyway, maybe not. So questions 7 and 8. Find the sine of 30 and the cosine of 30. So if you haven't figured this out, all we're doing is just running right around the circle. We're just running right around the circle. We started at 0, now we're at 30. So you're going to need to know the coordinates over there. The sine is this vertical height, which looks like it's smaller than that horizontal distance, so the sine is 1/2. And the cosine is a square root of 3 over 2. Good. So the cool thing is, check this out. I'm just going to clone that. So the sine is the y coordinate, and the cosine is that x coordinate. How are we doing so far? Good? Okay. So questions 13 and 14. What is the sine of 45? The sine of 45 and the cosine of 45. So here's 45. Do we know the coordinates up in there? These are the identical twins, aren't they? Yeah, this one's rad 2 over 2. And this one's also rad 2. Whoop, I meant for that one to be a different color. And this one's rad 2 over 2. So because of that, the sine is rad 2 over 2, and the cosine is also rad 2 over 2. Making sense so far? Good. For completion's sake, we're going to go ahead and go all the way around. So 13 plus 6 is 19, so I guess this is question 19 and 20. The sine of 60, the cosine of 60. 19 plus 6 is going to be what, 25. So 25 is going to be the sine of 90. 26 is going to be the cosine of 90. Yeah, and we'll talk about how to get the other stuff in a minute. So basically, we're kind of going through 1/3 of it right now. 25 plus 6 is going to be 31. So question 31 is going to be the sine of 120. And question 32 is going to be the cosine of 120. Okay. So the cool thing is the day of the test, attached to your actual test, there's going to be a blank unit circle. What I would do is take the first 3 or 4 minutes, fill it out, and there's almost all your answers. So if I go to 60 and 90 and 120, I'm going to need to know these to answer these. So what are the coordinates over here at 60 degrees? 1/2, and then red 3/2, and then up at the North Pole, 0, 1, and then when we go into the second quadrant, when we get to 120, the coordinates there are -1/2 and red 3/2. So you got to kind of watch that now our x's are going to be negative. So the sine of 60, what's the sine of 60 going to be then? Red 3/2. Whoop, I should have made that blue. So the sine of 60 is red 3/2. The cosine of 60, 1/2. The sine of 90, the sine of 90 is 1. The cosine of 90, 0. And the sine of 120, red 3/2. And the cosine of 120, -1/2. How are we doing with this content so far? Does that make sense? Pretty easy, huh? Like I said, going into the test, you're going to know the 96 of the 100 questions on the test. Well, I'm glad you asked. What the question was, what are the other 4 going to be? The other 4 are going to deal with coterminal angles. Coterminal angles. C-O-T-E-R-M-I-N-A-L. Yep, coterminal. So one of them I might ask you, what's the sine of 1,420 degrees? Something like that. And you're going to have to do the maths and figure out where that puts you on the unit circle. Coterminal angles, by definition, are angles that end up in the same place that have a different number assigned to them. So if we think about this, we know 360 is 1 revolution, right? We know 720 is 2 revolutions, right? We know 3 revolutions, 1, 2, 3 revolutions would be 1080. So I'm getting there. So what's the difference between 1420 and 1080? 1420 minus 1080 is, do what? Oh, you could divide it by 360, yeah. But then you might need to kind of be good with the fractional part. And it probably shouldn't have been 1420 because that puts us at 340. And 340 is not even on our circle, is it? So maybe I should make this 1430 or 1410. Anyway, it'll be something 1410, I think. 1410, sorry. 1410. 1410 minus 1080, that's 330, okay. So 1410 minus 1080 is 330. So where that 1410 puts us is there's 1 time around, 2 times around, 3 times around, and another 330 beyond that, which essentially puts us at the same spot where 330 is. Does that make sense? Yeah, yeah, and we'll talk more about that as we get closer to. So yeah, let's see what happens if we try your theory. So 1410 divided by 360. So that's 47/12 or 3. See, here's where it gets weird. It's 3 times, but then 0.916666667. You'd have to multiply that by 360. So it's 3 times and then another 330. Yeah. Okay. So So let's keep on trucking with this. We're up to 31 and 32. So I guess we're going to go to, what, 37 and 38. It's going to be the sine. Where did we leave off? 120? So that's going to be 135. Cosine 135. Another 6 is going to be 43 and 44. So that's going to be the sine of 150. Cosine of 150. Another 6 is going to be 49 and 50. That's going to be the sine of 180 and the cosine of 180. So again, you got to know the coordinates at these various points. And this is why I'm having you memorize the unit circle. This is what it's all about. It's a calculator. So here at 135, what are the coordinates there? We know it's going to be over 2, and it's going to be over 2. Rad 2 for both. And negative on the x. Good. Nice. And then when we go to 150, our coordinates are going to be what? Negative rad 3 over 2 and 1 over 2. And then when we get out here to 180, our coordinates are negative 1, 0. So now, sine of 135 is just going to be the y coordinate there. So sine of 135, rad 2 over 2. Cosine of 135, negative rad 2 over 2. Sine at 150, sine of 150 is going to be the y coordinate at 150, so it's going to be 1 over 2, cosine of 150, negative rad 3 over 2. Moving on down to the sine of 180. Sine of 180 is 0, and the cosine of 180, negative 1. We're going to complete this. We're going to go all the way around so that you can see the answers to approximately 1/3 of the big test you're going to take on this. I'd really like to do it before spring break, but I don't know that we'll get that far because of the testing. There's ELA air testing going on. Okay. So let's see where we left off. We left off with 49 and 50. So I guess we're going to have 49 and 6 is what, 50? 49, is that 55? So 55 and 56, and then another 6 is going to be what, 61 and 62. And another 6 is going to be 67 and 68. And another 6 will be 73 and 74. Okay. So this is going to be the sine of 210 and the cosine of 210 and the sine of 225 and the cosine of 225 and the sine of 240 and the cosine of 240 and the sine of 270 and the cosine of 270. Okay. So moving on around to 210, that's going to be over 2. Over 2. They're both negative here. What's my x coordinate? That's going to be the rad 3, right? Because remember in the southern hemisphere, it switches 3, 2, 1 down. So my y coordinate there is negative 1/2, right? Okay, so moving on, and that was at 210. So moving it to the 225, my coordinates at 225 are going to be what? Rad 2 and rad 2. Moving down here to the 240, the coordinates, again, they're all negative, and it's, what is it there? What's the x coordinate there? One-half. The y coordinates are rad 3 over 2. And then down at the South Pole, the coordinates down there are 0, negative 1. Okay. So the sine of 210 is negative half. And the cosine at 210, negative rad 3 over 2. Sine of 225, negative rad 2 over 2. Cosine of 225, same thing, negative rad 2 over 2. Sine at 240, negative rad 3 over 2. Cosine at 240, negative a half. And then down at 270, the sine of 270, negative 1, and the cosine of 270, 0. We're almost home. We're almost home. How many other tests have you taken where you know the answer to 96 of the questions before you even take the test? It's just a big puzzle, right? Pulling the right pieces out of the puzzle and putting them where they need to go. So. Got him? Okay. So the next one will be question 79 and 80. So this is going to be the sine of 300 and the cosine of 300. Another 6 is going to be what, 85? Well, 73 plus 6. Yeah. So we got the sine of 315. Whoop. Sine of 315. So 86 will be the cosine of 315. And that's what, 91 and 92. That's going to be the sine of 330 and the cosine of 330. Okay. So again, when you take this, strategy is going to come into play. You know, maybe you won't even fill out a unit circle. Maybe you'll just know it well enough you don't have to. I got to be honest with you. I took this test. I took it in 17 minutes, and I didn't even fill out a unit circle because I know it that well. And I'm not saying that to brag. I'm just saying that if you know it well, it's going to be pretty straightforward. So here at 300, what are our coordinates down there? 1/2 for the x and negative rad 3 over 2 for the y. Good. And then moving over here to 315, the coordinates there are going to be rad 2 over 2 for the x and negative rad 2 over 2 for the y. And back to 330, our coordinates again are going to be over 2's, and it's going to be what? Not rad 2 and rad 2, and not at 330. Well, we're at 330. Rad 3 over 2 and negative 1/2, right? Okay. So the sine of 300 then? Negative rad 3 over 2. And the cosine of 300? Cosine of 300? 1 over 2. Sine of 315? Negative rad 2 over 2. Cosine of 315? Rad 2 over 2. Sine of 330? Negative 1/2, and then the cosine of 330? Rad 3 over 2. So that's how the unit circle ties into, well, how right triangle trigonometry, I should say, ties into the unit circle. Okay? X is the cosine, Y is the sine. Cosine, sine, cosine, sine. X is a cosine, Y is a sine. It's alphabetic order. What do you think? Make sense? Now, you're probably questioning, well, what about the other ones? We'll talk about those in a future date. Okay. We'll talk about the tangent soon enough. We'll talk about the tangents on Friday. If your class doesn't meet tomorrow, the next time your class meets during that testing, we'll be talking about the different unit of measure for those angles. Okay. So that's it for this lesson. You know, 360 is back at 0 again, yeah. So it's just those when you're back here at 360, it's the coordinates are 1, 0, right? Yep. Okay. So that's it. Any shout outs? Garrett Epperly gets a shout out. Shout out to Nate Pitzinger. Shout out to the future Mr. Minnick for being such an awesome guy. And Double Cola? Bubba Cola, okay. And good luck on the quiz that you're going to take in a few minutes. See you. Good.